talking about? This is a 1 to 2 ratio, as shown in yours. 1 to 2, right? So what he's saying is this should be 1 to 2 as well. So if you have a 1 to 2 ratio, he divided the 1200 into 3 equal pieces, where the one over here is the 1 and the other one is the 2. Well, 3 equal pieces means it's going to be how long here and how long here? 800 and 400. So it's still at a 1 to 2, the 400 to 800. And then you're saying from that 400 to 800, your Pythagorean theorem will give you that shortest distance, is what you're saying.
I don't know why similar triangles should cooperate with that. But.
Well, he actually has kind of a feel, and he tied it back into what we saw in the indirect measurement with our mirrors. Do you remember that? Where the person standing here, and we know that the angle of incidence is equal to the angle of reflection, and therefore by the A shortcut we could set up similar triangles. I'm going to show you a way to solve this using the ideas of the unit, which are, what are our big ideas of the unit? We've got 3 big: symmetry, transformations, and tessellations, and they're all related to each other, but we're going to solve these real-world problems here using those ideas. So, if you'll watch, maybe I better turn this off. Okay, so if we go to GeoGebra and start with a new file, we don't want that on. Where it came from. Okay, what I'm going to do is I'm going to go up to Edit and put Insert Image from a file. And I've already got this shortest path diagram here that I've saved. By the way, if you want to know how to get the image, just open it in GeoGebra. If you want to know how to get the image, what you do is you just go to Word, you right-click the file, and you put Save As Picture, and then you type the name of it and save it where you want. And I suggest you save it as either a portable network graphic PNG file or a JPEG file. One of those two. And then just save it there. That's how I got that file. So now that I'm in here, I went to Edit, Insert Image from File, and that's how I brought it in. Okay? Now what am I going to do with it? Well, I'm going to, first of all, bring it up. Notice that I can control it with these 2 points that, where does C come from? Click on it. There we go. Now, what I'm going to do is, I'm going to come to the line tool, and I'm going to create a line along the edge of the river. So I'll click a point there, and a point right there. Now I've got a line going along here. Okay? So now, what I want to do is reflect this picture across this line. So I'll come up here to Reflect Object About Line. It wants me to click the thing to select the part to reflect. I want the image. And then the line to reflect it about. And notice what happened. Picture flipped. And now what we're going to do is we're going to go up here and I'm going to get a segment. And I'm going to connect the pre-image point A to the image point B. And the place where that segment intersects the line of reflection is the place where you want to go to pick up the water that will make the shortest distance. Why? You'll notice, as I reflected the tint down here, the shortest distance from point A to B prime is the straight line, the segment going there. Does that make sense? So, since this segment right here is the reflection of this one, then that length is the same as that one. Is that making sense? So this point will be the shortest distance. So I grab a point and I get right here, and that is the point where I want to pick my water up. Okay? Does that make sense? We actually used a reflection to solve this problem. Okay? The next one. New window. I want to insert the other image, which was the pool table. Okay? Move that up there. Now, let's go back to our problem. Two balls rest on a billiards table at points A and B. Find the path ball A must take to strike ball B, but first bounce off of side 1. So it's going to come down here and it's going to bounce here and come back. Well, we know that light, the angle of incidence is equal to the angle of reflection, but it's also true of billiard balls, pool balls. The angle that it strikes the cushion is the same angle that it leaves the cushion. Does that make sense? Unless, of course, you've got some spin on the ball, a little English or whatever, which causes things to change. But if it's a direct hit and it's moving... Okay, so the way we solve problem A is, notice we're going to reflect it on side 1. Okay? So, what we're going to do is we're going to go to GeoGebra, and I'm going to take and place a line along side 1. So I go right here, click, and right here, click, and C is not quite on the corner, even though I tried to... Okay, does that look like it's along side 1? You okay? Now, what I want to do is reflect the entire pool table. So I come up here to the reflect. I click on the image to reflect, and then I click on the line to reflect it over, and it reflects it over that. Now, what I want to do while I've got this image, I want to show you that you can click on this object properties and you can go to, where is it? Change the opacity. There it is. You can make it so it's more transparent. Let's see what that does, giving it a 50%. You see how it's so that I can, here's the side 1 word that got reflected, and here's the side 1 word. I can actually see it now through the pool table that I reflected. Okay? Now what do I want to do? I want to come up here, get my segment. and I want to connect point pre-image A to, come on, to image B. And that is where I want to hit the cushion on side 1 so that the ball A will bounce and hit ball B. Does that make sense? And to prove that that's true, I'm going to take this reflection again, and I want to reflect this segment across this line and see what happens. There's actually the path of my ball. It's going to come down, hit, and come back up. Now, how do we know that that's true? Well, I know this angle is equal to this angle because they're what? Vertical angles, right? And this angle is the same as that. I just reflected this angle here up above. So those angles are the same. So now I know the angle of incidence is equal to that angle of reflection for the ball. So, this may sound just a bit quirky, but how many of you are pool players? You want, maybe there's a bunch of balls between you and the ball you want to hit, so you can't hit it directly. But you know if you take a cushion, you can avoid those balls and then reflect it and hit it. So what you want to do is you want to picture the pool table, see the pool table in front of you, and then picture the exact mirror image of it, that pool table being flipped, and see where the image of the ball that you want to hit would be. And then just shoot straight for it. You know what I'm saying? You see this pool table in your mind with this reflection here. And then that ghost ball, it's not really there, you just aim for it, and in doing so, you will hit on a reflection. Does that make sense?
What kind of gets me, I would have never thought of doing this, but is it just because you draw a segment from A to B because you want to hit B?
Yes.
Okay.
That's why.
Okay.
And I want to hit it after one reflection, so I'm doing one reflection. Let's continue. All right. I'm going to get rid of, let me look what I want to do first. Reflection of side 1, then side 2. Okay, so I want to get rid of, we'll click here, I'll undo this to that level. All right, let's go back to our problem. Our problem says, new problem, we've got ball A and ball B. Where would you aim for on side 1 if you want to hit side 1 first, then side 2, and then have it hit the ball B? Well, what we're going to do if we wanted to hit side 1, then side 2, is we're going to reflect it first across side 1, which we have done. And now we're going to reflect it across side 2. So I'm going to make another and it looks like I'm not quite with a little better. Does that look like it's along the side? Okay. Now what I'm going to do is I want to reflect the image across side 2, which is this line. You see what's happened? Okay? So what I'm after is I want to shoot from A, bounce off of side 1, bounce off of side 2, and hit B. So what I'm going to do is I'm going to come up here and I'm going to grab my segment and I'm going to go from the pre-image A to the double prime image of B. Come on, get rid of that. There we go. Those look like they... All right. Well, guess where I'm going to aim? I'm going to aim right there. Okay? So, let's just put a point there. If I aim right at that point, it will not only reflect off of side 1 properly, but it will reflect off of side 2. Let me show you what I mean. Let's take and select this segment. That tells us it's this segment, and I'm going to hide that. And I'm going to put in a segment that is going from here to, here's where we're going to reflect or go to, right? And now what I want to do is reflect that point, that segment across this line. How come it didn't work? There it goes. And now that's where the ball will hit that table. Can you see that? So now what I'm going to do is put a point at that intersection. Boom. And now I'm going to hide that one right there. Hide. And we might as well hide this one. And what I'm going to do now is put a segment from just here to here. And then I'm going to reflect it across this line. So I'll click here. Say I want to reflect this segment across this line. And guess where it hits? B. So my path will go here, here, here. And I can find it by what? By making two reflections, first inside 1, then inside 2, and connecting A with B double prime, and that will give me my path. So, getting these back, well, I guess we'll just turn them back on. Which ones were they? Let's see. That one, we don't need that one. We don't need that one. Or that one. I guess we need to make them.
So how did you know to go from B to, or A to B double prime?
Because the problem says I want cue ball A to hit cue ball B after a reflection inside 1 and then 2. So what I did is I reflected the pool table inside 1 and then across side 2, and I just, if I'm headed for B, I just go from where I want to start to where I want to end on that last reflection, and that will be my path. And it will, if we were to measure this angle and this angle, they're going to be the same, these two. And if we measure that one and that one, they're going to be the same, and therefore there's my path. And let's do one more. I want to get rid of, let's see. There we go. Well, maybe even some more of those points. Okay. Now, going back to our problem, it says, what about reflecting it over side 1, then side 3? what would we do? I would make this reflection, and then where's side 3? Right here, I would reflect it again across this line, right? So let's do it. G right down there, so it's on the... Okay. Now what I want to do is reflect this image, this first image, across this line. So we come up here, click on the image, click on the line to reflect it across, and there it is. Now, what do I shoot for? Abby, have you got it figured out?
B double prime?
I start with this A and go to this B, right? Which means it will go here, come back up here, reflect off of there, and come to B. You see how? If I shot for this spot right there,
Yeah.
this point on my original pool table, it will reflect just perfect, so it comes up here, just perfect, so it comes back and hits B. Because I went across side 1 first, and then across side 3 next. And that's how to do the part C. Now I don't know that we want to go through D, but we could. Side 1, then side 2, then side 3. So we want it to bounce, 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 and then hit. Right? What would we do here? We're going to reflect this one across here, that one across 2. It was 1, 2, and then what? 3, which is down here, right? So now I've got to reflect this one across this line. Let's see. I reflect this one. Reflect this one across, oops, this one, right? Did it work? No. What's going on down here? That is weird. 2 input lines. Trying to make my all right. Reflect this image across this line. There we go. Now notice, this, if I shoot from A to the B here, that's where I'm going to want to hit. If I hit there, it will hit 1. It will do the right bounce, hit 2. Do the right bounce, hit 3, and hit B. Because I went across the reflection line, side 1, across the reflection in side 2, and across the reflection in side, and I put it to B in that last one. Does that make sense? Let's just show that it really will. This is my shot, so I want to reflect this across this line. Okay, let's try it again. We want to reflect this segment across this line. There we go. And it's going to hit this one right there. Now, I want to reflect this one in this line of reflection, 2. And now I'm going to have to come up here and put a line there to reflect it. And we want to reflect, let's see, this segment across this line. And look where it hit. B. Okay. So, on day one, we gave you the shortest path in a mini golf. Does everyone know how to solve mini golf now?
Yep.
Let's see. Tonight's homework says here's the mini golf. What do I need to do? I need to right click this, save the picture as mini golf. And we're going to save it as a King file. And where am I going to save it? I'm going to put it right here in 306. There. And now we're going to go to here and say new window. And I'm going to import that image from a file. There it is. And what do I want to do with it? Well, the hole is here. The T is here. I need to bounce off of a wall and end up in the hole. Does it matter which wall? No. I could bounce here. I could bounce here. But where am I going to hit? Which wall do you want to bounce it off of?
The top.
Top one?
Yep.
So what do? Make myself a line of reflection up here. Now what? I want to reflect the image across this line. Sometimes it says select the object to reflect. That's this. Worked that time. Now notice how this edge, this picture that I just brought in has a white edge on it, which makes it so I can't see this. What can we do? Object properties. Go to color. Change the opacity so we can see through it. That will allow us to see the other green. Okay. Now what? Draw a segment from where to where? The T on the original to the hole on the image. And that point right there, right there, because now we're seeing that point right there is where I want to shoot for. If I do that, it will go right in the hole. How do we know? Well, let's do a reflection of this right here across that line. And look, boom, boom. Okay? Sketchpad works the same way as. Now, the question we'd asked earlier, more than once, was how can the ideas of symmetry, transformations, and or tessellations help you to, or how does it apply in real life? Here's one way. playing pool, playing mini golf, finding the shortest path. Does anybody have questions about what we did or why we did it or why it works or the procedure you're going to be using? Okay. On this particular if this is your billiards table, where are you going to put your line of reflection? It's a little bit different than the last one. You going to put it right along here?
No.
Or are you going to put it along here?
Along there.
Where does it bounce from, those of you who have played? This is the cushion, so it's going to bounce there. That's where we're going to want to put our line of reflection. Does that make sense? Or along this one, not this one. And then when you do that, unless you change the opacity, it's going to actually cover part of it up, so you'll need to change that so you can see through it to be able to see that particular reflection. Okay? Questions? How about, I've had a number of you come to my office for your tessellations. Does anybody have tessellation questions that we could answer?
What file do we find the information, like the procedure on? I can't remember which file we find on it.
Is it making tessellations?
So step by step.
You go to make your own tessellation and then
There's one called Making Your Own Tessellation, which had the homework in it.
Yeah, with
It's
all
got
these.
all of this stuff right here. Okay? And let's just go out here to GeoGebra Tube. I want to search the user list. The user list is BYUI. And there is the, oh, hey. Somebody's made their own file and put BYUI there. The one that we want is the collection. Let's see here. Notice these tessellation steps. Can you see those in there? These are ones that we saved in there for putting the collection together. And then, let's see if we can find the collection. Come on. There we go. By the way, the videos and the other things that you've seen throughout the semester, here's where they're located, when we have links to them oh, here we go, collections. There's the collection right there. Okay. So that's 6. That's not the one. I'll give you a link to the collection and show you how it looks when it's all done here. Has everybody been able to build that collection and put it together?